Hello, everybody. We're still talking about the stripping, and we saw in the last video how we can calculate the number of stages for the number of theoretical and actual stages for stripping column, and we were able to calculate the number of actual stages based on the overall efficiency of the column. In this video, we will see something that we saw before. If we are dealing with a column and we know the stage efficiency rather than the overall efficiency, how we can deal with it. So we saw in the absorption case that um, we calculated the actual y, which is the mole ratio in the gas phase, from the theoretical y, or from the ideal value of y, based on the efficiency of the stage. And in this case, it's going to be the opposite, the opposite to what we did in absorption. In absorption, our focus was to purify the gas, so we were interested in the mole ratio of the solute in the gas phase in coming out of each stage. In this case, in case of stripping, we are interested in purifying the solvent or the liquid phase. So the efficiency will be calculated based on the mole ratio in the liquid phase, not in the gas phase. So it's gonna be similar to what we did before. And instead of going from this point to this point, we're gonna go to somewhere in between due to the efficiency of the stage. So we have to define the stage efficiency, and we need to give it a value. I'm gonna say like 40% for now. And we need to first think how we can organize the file. So one important thing that you need to keep in mind is that you have macros, and the macros are kind of limiting your flexibility of adding and removing columns to the file, because as we saw in the script before, that everything is written in terms of the cell name. So if you change the cell location, then it's very probable to make errors in the code that you write. So I would avoid adding anything in here, so that or between this column and this column, so that, or I mean before this column, so that I keep everything in the macro script as it is. I'm not gonna add any rows, so everything I'm gonna add is gonna be here, or starting from here. So this is why I'm gonna add two columns here, and it's gonna be very similar to what we did before. I'm gonna do here the x actual, and I'm gonna call this x ideal, and this x actual is gonna start, or is gonna start with the same point as this, and the actual is going to be calculated from the efficiency, which is the feed to the stage minus the efficiency, and click F4, multiplied by the theoretical separation, which is this minus this. So this is the actual value that's going to come out of the stage that has efficiency of 40%. And as we said before, one thing that you can check or you can do to check this number, is to make sure that it lies in between these two values. So it looks okay. And here, this second line of the stage should start by the end of the first stage. So this is gonna be it. So these are the x values, and these are the y values for the first line, and this is for the second line. I'm gonna copy this and paste it here. um, Copy and paste, so that I make sure that all the changes I made are copied in the following rows. So this is calculated from here, and this is calculated, so everything looks fine to me. So I'm gonna go here and repeat everything. I'm just pasting, so I'm not doing something fancy here. And that's all. One thing that I think I forgot to do is to make sure. No, I think this is okay. Yeah, this is okay. It's already done. And this is what you can see here, that the values are changed. And one thing that is different from here, or from what we did in absorption, is that you have to do the calculations every time you do any single change. And here you did like a bunch of changes here in how many, like 15 stages. So you have to recalculate output from each stage. And luckily what I did didn't change anything in the in the macro calculation. So you just need to press on the calculate button and it's gonna calculate. And you see here the 15 stages are still not enough, and this is what I should expect in a case like this. We needed 11 stages and the efficiency is 40%, so I should expect that I need more stages. So to save time, I have already done this and I have gone to 31 stages. You see I did this like 31 times. And as you see, this is how the curve looks like. And I copied the graph so that I can take a better look at it at like zoomed in version. And as you see here, because the efficiency is low and actually the original driving force is not that high, so the driving force is getting very weak here in this part. So we have to have a lot of stages so that we can achieve the required separation. And we have already gone for 31. Just to have a quick comparison to what we saw before, we needed 28 when we used the overall efficiency of 40%, but for stage efficiency of 40%, I needed 31 stages. So there is still a difference, but it's not that much difference. Just one thing that I need to check with you. If I change it to 45% efficiency, you'll see that these values shouldn't be right, because the uh, the numbers here are all not zero, so I have to recalculate everything. So you could see that these numbers are changing because it's doing the stage calculations one by one for 31 stages. So it's doing 31 gold seeks in consequently, or successively. And you see that this is updated automatically, and this is one thing that like makes you happy with what we did. It's a beauty of what we did, is that you are extracting the new equilibrium curve data, and you are plotting the stages, and you have already all the data, the numbers of the outputs of each stage, the theoretical and the actual number of stages. So I know it's tedious process. Like for this case, when I did added the lines, you see there is a big list of lines. All of these are lines. I added like more than 70 or 65 lines for 31 stages. So each one is composed of two lines. So it's 62 plus the original lines for the operating and equilibrium and the new equilibrium curve. So it's like 65 lines. But I did it once, and every time I change anything in the inputs, even if it's related to the equilibrium data, the inputs to the flow rates, whatever the type of change, I'm not gonna do anything new to this part, and it's gonna be calculated automatically. So I hope you like it, and I'll see you in the next video, inshallah. Goodbye.